Hello beautiful people. We go through life taking a lot of things for granted, but there are a few things we see every day that can give us some shocking revelations and possibly freak us out. And yes, in this video, I am going to drop some science on you. We tend to think of darkness as being the opposite of light, and cold as being the opposite of warmth. But darkness and cold don't actually exist, even though warmth and light do exist. You see, darkness is actually the absence of light, whereas coldness is the absence of warmth. To think of it another way, you can shine light on something, but you cannot shine darkness. And if we want to heat something up, we add heat energy. But to cool it down, we have to remove heat energy. This does make me wonder about drunk and sober. All things on this planet reproduce. Mammals give birth to live young, reptiles and birds lay eggs, plants use seeds, and parliamentarians, I assume, use some sort of cell division. In all higher organisms, there has to be fertilization of some sort happening. In any plant though, pollen has to get from the male reproductive organs to the female reproductive organ. This can happen in a number of different ways, but one method plants use, if they don't have a flower, is to fill the air with pollen, let the wind carry it, and hope there's a lucky recipient at the other end. However, the most common way in which plants do this is by having flowers. Some flowers having both male and female bits, and some flowers having exclusively male or exclusively female bits. So when you get hay fever from all the pollen in the air, it is your body overreacting to what is essentially plant sperm that you are breathing in. And when you are giving your girlfriend a bunch of flowers, what you are really saying is, here, have some vegetable vaginas. People tend to have a freak out when they hear the term radiation. But in actual fact, most things in this universe are radioactive, including humans. Light, heat, microwaves, radio waves, X-rays, gamma rays are all classified as types of radiation. More specifically, electromagnetic radiation. The difference between them though is the frequency of the energy waves. So when you say someone is a beacon of light, it would be much more accurate to say that they are a beacon of electromagnetic radiation with a wavelength between 400 and 700 nanometers. But I suspect this will not catch on as a Valentine's Day card. Human vision is trichromatic, which means we have cones in our eyes that can see blue, green, and red light. And we can tell how bright a light is by the intensity with which it hits those cones. But if we can only see those three colors, how can we see yellow? Light we perceive as yellow is not made up of two different colors. It is actually one color with its own wavelength. The way we see yellow is that the cones in our eyes cannot only detect red, blue and green, but can also detect a little bit into the other color spectrums as well. The problem comes in that to our green cones, yellow looks like a very dark green, and to our red cones, yellow looks like a very dark red. It is the brain that then interprets these signals and we see the color yellow. So in actual fact, you cannot see this image. You're really just imagining that it's there. Ants are some of the strongest creatures on the planet, and they can carry between 10 and 50 times their own body weight. So you would think that if you scaled an ant up to the size of an average human, it would be able to carry an elephant. But actually that is not the case at all. Enter some math. Let's start by looking at the formula used for calculating the volume of an object. It's the length times the width times the height, which gives you the volume. So if something is 1 meter by 1 meter by 1 meter, it has a volume of 1 meter cubed. and something that is 2 meters by 2 meters by 3 meters has a volume of 12 meters cubed. Now if you take a 3-dimensional object and you make it 10 times bigger, the volume of the object doesn't increase by 10, it increases by 1,000. Just like 1 times 1 times 1 equals 1, 10 times 10 times 10 equals 1,000. And since weight is directly related to volume, the weight of the object increases by 1,000 as well. Ants weigh from 1 to 5 milligrams and can range in size from 1 millimeter up to 30 millimeters. So let's take an ant that is 6 millimeters long and has a weight of 3 milligrams. And for argument's sake, let's say he's extremely strong and can carry 50 times his own body weight. That means he can carry 150 milligrams. Now we increase that ant size 300 times. That means we now have an ant of 1.8 meters long, or 1800 millimeters. That is a little bit shorter than I am. And this ant now weighs 81 kilograms. That is 27 million times heavier. But the surface area of the ant's legs, which carries all that weight, has only increased by 300. This means that our unfortunate ant can only carry 14 kilograms, and it ends up being crushed under its own weight. For a more in-depth explanation of this, I put a link in the doobly-doo. The Earth is rotating on its axis every 24 hours, and it has a circumference at the equator of 40,075 kilometers. So if you are at the equator, that means you are traveling at 1,670 kilometers per hour just by standing still. But that's not all the Earth has to give us. The Earth takes roughly 365.25 days to complete one orbit around the Sun, and the circumference of that orbit is 940 million kilometers. So if we do some math, we find that us and the Earth is flying through space at 107,000 kilometers per hour. That means you can fit the entire Earth between where you are right now and where you were 7 minutes ago. I can just somehow imagine an alien landing on Earth, getting out of his spaceship, walking up to you and going, "Do you have any idea how fast you were going? Let me see your license." If I were to shuffle a deck of playing cards, you would have 1 in 52 chance of guessing what the top card is, a 1 in 51 chance of guessing what the second card is, 1 in 50 of the third card, and 1 in 49 of the fourth. So if we do some math, we find that the chances of you guessing the exact sequence in a randomly shuffled deck of cards is 1 in 8.065 times 10 to the power of 67. Yes, it actually is that big. To compare that figure, the universe is 13.7 billion years old, which is a measly 10 to the power of 18 seconds. It means that if you shuffle these cards really well, chances are that it is the first time in the history of the universe that a deck of cards are in this order. For a more in-depth explanation of these figures and for some really amazing card tricks with math, I suggest you watch the Vsauce video that I have linked in the description below. Well guys, that's it from me. If you enjoyed this video, please show that like button some love, share it on social media, and subscribe by clicking the big red floaty thing. If you have any more strange facts or there's anything you can think of that you would like to see a video on, let me know in the comments below. Have a good one. Cheers. Okay, papa is nou moeg en fucking gatvol en o, jere, julle beter record.